So yeah, my name is Thomas. I work for Sonar in the R&D team. So I'm a vulnerability researcher. I go by Swap.js on Twitter, but I don't go on Twitter anymore. So on Mastodon and other websites. And so my company helps developers to write clean code. So we have 7 million developers using tools like SonarQube, Sonar Cloud. So for both quality, maintainability, and security. And on our side, in the R&D team, we try to push for product innovation, so to have like better technology, to be better at finding security issue and quality issues and all kind of issues. So in our case, we find 0 days that we responsibly disclose, and we then use it for product innovation. We've had more than 150 findings over the last 2 years. We got Pony Award nominations, Sports Riggers Top 10, Reworking Techniques, we did Pontoon, and so on. So it's a pretty fun team. And I was looking to do a talks like in France, and I was like, okay, where should I go? And GreHack has an awesome reputation, and the tagline is "New is not always better." And I was like, oh yeah, that's true. And so I was looking at some CVs, and there were way too many CVs, like 20,000 CVs this year so far. And there is one kind of CVE, one bug class that I really like, and they had maybe 163 argument injection bugs, but not this year, since 2004. So it's like there is a huge difference, and that kind of means nobody's really finding this kind of bugs anymore. I feel like it was a thing at some point, but it's not anymore. It's weird. And at the same time, we've had 20 of these findings over the last 2 years. That means we've been finding most of this bug class in the last years, which is kind of weird, but it kind of makes sense. I don't know who said it. Maybe I just dreamed of this thing. But like you only find what you're looking for, and I think it's really true for security. If you don't know about the specific bug class, there is no way you will just find by yourself. And I really believe that when you have some intuition, some experience, and you kind of come to a new target, you're like, oh, could be interesting to look for this kind of specific bugs. It really helps you to find bugs really, really fast. Even if you will miss maybe 20 other bugs. And also Agari, so Nicolas Grégoire, I think it was on the I Can Speak podcast and also in his trainings, is always, yeah, you need a differentiating factor. Like you need to be able to do things that the other can't do or can't find when it comes to security research. And I mean, argument injection, it's AI, it's hype, so it's also a good reason. And when I was talking about kind of everybody, like security practitioners, like pen testers, or even web devs interested in security, they kind of know argument injection, kind of rings a bell. I mean, there is injection, but it's not really part of the toolkit, so they don't really want to use it. There is a huge taxonomy mix, everybody's mixing option injection, flag injection, parameter injection. Like, is it the same thing? Yes, but nobody's calling it the same, so it's also weird. And they also sometimes think it's unexploitable, like there is nothing you can do with it, so why would you bother looking for this kind of bugs in the first place? And I also lied before. I said there were 163 CVs since 2004. It's false, because most of them are bogus. And everybody's mixing common injection, argument injection, and everybody's mixing SQL injection with argument injection, because they're like, oh yeah, this comes from some argument in some function, so it's an argument, and then it's an injection, so it's an argument injection. And as we'll see, it's not a thing at all. So I want to get back on maybe the basics, which makes sense to just set up some strong foundations for everybody to understand what's an argument injection, because there is a weird terminology for a few things, but that really matters in this case. Then we can look at some bugs, some real-world bugs that we found, how to prevent it, and then maybe some contribution we did to some other project and some ideas we've had. And so the goal is really to both discover, exploit, and remediate more argument injection bugs. So I think you're kind of familiar with what a shell is. So this is your command line. On the left, we have a command, which is foobar, and then we have arguments. This thing is really specified. It's not magic. It's not things we've came to say, oh, this thing is called an argument just because it looks like it's called this way. There is this POSIX specification that really says this thing should be called an argument. And then if you kind of zoom in, you have the options or the flags with --foo, --fizz. Then you have the option arguments. This is like an argument of an option, which starts to be weird. You can also call it a parameter, which is also kind of like what's the difference between a parameter and an argument in the first place. And when you have a value that's not prefixed with dashes, it's called an operand or positional argument. So there is a lot of terminology, and they all mean something really, really different. So if we take a common injection, like you control some data, and in this case, you have the bash command substitution sequence. So this is typically the case of a command injection. So you control everything that's in red, and the program will maybe concatenate this value that you control with some other command and execute everything in the shell. So the execution steps would be the exact VE, so it would run everything in the shell. So it would call sh that would pass this chain, this command line. So we'd have git status and our payload, and it would say, okay, it's like a shell script in this case. So it would first execute date from the command substitution sequence, and then call get status with the output of date in the next parameters. So this is typically what we call a command injection. And when you want to fix it, you're going to you have two ways to fix it. Usually you can use the escape, any kind of escape function to make it a shell string instead. So that way the shell thinks it's a string, and in the context of strings with single quotes in bash or in shell scripts, it's not going to evaluate the command substitution sequences. So in that case, it's only going to call get status and a string, which is perfectly safe. Another way to fix it would be to execute things without a shell. If you don't have this shell that does the command substitution replacement, nothing happens. You only call get status and date. So you say, yeah, everything's fixed, right? But in practice, in the first case, if you, in the payload, you omit, you forget about everything that's shell related with commands and everything, but you put like --help, the execution steps would be simple. Like we would give it to the shell, we would call get status, it's a string, cool. Bin.sh passes everything as a shell script, it's only an argument to get status, and the final execv calls get status --help, which seemed to be something interesting in this case. And if we look at the same as a second fix, the second way to fix such bugs, so without a shell, we also go through execution steps, and we call get status --help directly. So in this case, we know we can inject an argument. --helps may look safe for now, but it's definitely going to print the help in this case. So when trying to fix a bug, we've introduced a new bug, so maybe interesting security-wise. And maybe developers all know about this thing, like SQL injection, like, oh, I should not concatenate unsafe data in MySQL queries. And nowadays everybody's using safer ways to do it. So maybe it's the same thing for argument injection. Yeah, maybe. But it's not. There are many, many ways to execute commands with the usual APIs. You can do it without a shell, which is a bit safer because you don't have this risk of command injection. So these are the APIs on the left. On the right column, with shell, you have all the APIs you can use to execute in a shell, which is a bit more dangerous. And then you have some languages without escape functions. You only need these escape functions when you're executing things in the shell. The only weird case is Node.js, where they don't have any escape function built in, and they still let you execute things in the shell. That means there are probably a lot of command injection in Node.js because they don't give you ways to prevent command injections by yourself. You have to re-implement it again. And when it comes to argument injections, it's even worse because nobody's mentioning this risk of adding extra arguments to the command in the documentation, except PHP. And you can say, yeah, PHP, it's not safe. But in the end, there is one comment from 8 months ago that says you should take care of not letting users add extra comments to, add extra arguments to the command. So somewhere somebody knows it's unsafe, but you have to scroll on the page, you have to look for it. So honestly, it's not really documented. That means no developers have ways to know about argument injection by reading the official API documentation of the things they use to execute commands. So there's definitely a risk of bugs. So it's super counterintuitive. We have to care about this shell layer. Like, I'm executing something with a shell or without a shell, and a shell, it's weird. You don't escape single quote with backslashes. It's like with single quotes. So it's like everything's tricky. You're like, yeah, but I used an escape function to make my data safe, so how come it's not safe in the end? No, you just reintroduce a different kind of bugs. And also you can say, okay, I'm only injecting help in this case, but like, can I maybe do something more dangerous? And I think overall, this is really because most remediation effort is short-sighted. So when you have a command injection in your, in your software, you try to fix it because it's like CVSS 10.0, I have to fix it right now. You don't think about the other risks you risk to introduce at the same time when trying to address it. So behind every single command injection I've seen not in my life, but close to 90% of them, they just forgot to fix the argument injection behind it. And we're going to see good examples right after this. So now we can start looking at bugs. So this is based on real bugs that we found with the team. So first there is a comment injection bug. So first there is always this risk of introducing argument injection when fixing comment injections. So we're going to see a case. It's not just one case. We've seen it with packages that I'm going to show you, with VS Code. Just everybody's doing the same mistake over and over. So something's wrong with it at some point. There's also some exploitation tricks to pass more than one option. We're going to see how it could be helpful in some cases with a use case on EL Finder. And we can also look at non-standard argument parsers, which starts to get tricky. But you will see that even when it looks like it's safe, it may not be safe. And there's so much more. Like I said, there were like 20. I tried to come with a specific project with many bugs in a specific project, especially for GreHack, but they didn't fix it. I didn't want to release everything at 0 day. So maybe we can later give this talk again with some even more bugs. So we can start by looking at some bugs in packages. Maybe some of you already saw it. I presented at Barback last year. So packages is backend of the PHP Package Manager Composer. This thing serves 2.4 billion dependency per month. So it's serving a lot of traffic. Everybody's using it to pull software dependencies and use them as a project. And we found 2 bugs in this project, and they are both argument injection bugs. And to also give you some context about how it works, Packagist doesn't host your repository, your dependencies. It only indexes projects that are hosted on GitHub or other locations. You import a project to announce it on this platform, and then it only stores metadata, readmes, and URLs. That means if you get RCE on the server, you can change the URL that's associated with every single of these dependencies. Like somebody tries to pull Symfony, you will say, oh, yeah, you can fetch Symfony from my server instead. So you basically get RCE on everybody who's trying to pull dependencies. So some other researchers in 2018, I think, 2018, Mac Justice, he found a command injection on Packagist. So I have the patch here, but it's easier that way. He would go on the main page, he would submit a package, he would put this, shell substitution sequence, you put some commands, it would execute it. Classic command injection. Like I said, behind every single command injection, there is an argument injection. And that's exactly what happens. In this case, if we look at the code behind this small form, the code that tries to import a repository, we see it's running git, ls remote, and then we have the escape function that we know that it protects against command injection, but it does not protect against argument injections. So it's here, and we have the execute right around. So it's like a really simple case of argument injection. If we look at the subversion version of this implementation, the same. We have the exec, we have the escape, but nothing that could be preventing any kind of argument injection, only command injection. Same with Mercurial, and so on and so on. So they tried to fix every single command injection, but they did not think about argument injections. So I'm going to talk quickly about the exploitation with Mercurial, which is like kind of Git, but for old people, kind of. No, I'm only joking. It's really nice. We can inject an option that's --config to override some configuration of the Mercurial client, and they support aliases, so we can re-alias the identify command with another one, and they also support shell commands in this case. So we can basically say, instead of running AJ identify, in this case, we override identify and we make it run a command instead. So we have our curl command, and then we leak the output of the current directory, so ls, to some server that we own. So we have our injected options, the configuration override, and the payload. So instead of putting the $parenthesis and our shell command, we put --config, alias identify, or shell command, and it works. And then you receive everything and you get RC on the server. So really simple case, 101 argument injection, and you compromise 2.4 billion downloads per month. We have also looked at some other developer-related projects. If you can compromise what distribute dependencies, it's good. But if you can also compromise where the code is hosted, it's even better. You can affect even more things. So we've looked at SourceHot, which is a really nice, opinionated network of useful open source tools for software project maintainers and collaborators. It's Git Mercurial repositories hosting. You have bug tracking, you have mailing list. It's like GitHub, but without all the Microsoft layer around it. So you have no AI, no all these kind of things. And we found multiple bugs in repository hosting features. So in the Git patch feature, in the Git archive feature, and in the Mercurial GraphQL resolver. So I'm going to show you the last one. So they created a GraphQL API around this repository hosting features, but it's also for every single feature on this service. And when you do GraphQL, you can directly map it to a database, so it fetches fields and attributes from data that's from your database, but you don't always have everything in your database. Sometimes, in the case of repository, you may need to fetch some information like the story, the bookmarks, branches, and tags. You have no reason to store this information again in a database. You can simply run Git or Mercurial clients to fetch this information on runtime when you need this information, and give it back to the GraphQL layer and give it back to the user. The reason why they use Git and HG in this case, why they could be using libraries for it, is that this client, they always if you update them, you always have the latest features, performance, bug fixes, everything. Libraries don't really follow the same update process, and sometimes they're lacking some of the features. So when you host source code and you want to do nice UI like GitHub, show history, show everything, you need to call Git, you need to call Mercurial. And in the resolver, there is a lot of code, but honestly not much happening in this case. We take the revision, which is a version of the repo, we put it in a command parameter, and that's it. Looks like a classic case of argument injections again. But it's kind of special because right before us, there is this -r, which means revision. So this is an option, and we inject an option argument, which sounds like we inject a value, so it's not going to affect the command itself. It's not going to affect the Mercurial client. But in 2013, I don't know why. I don't know if somebody knows why, but I would love to know. They did a patch that says that -config works everywhere. It works as an option argument. It works as an argument. It works everywhere. And it takes precedence over everything else. That means that even if it's used, you have an injection where it should be a string. It should be seen as a data, as an option argument. If you put --config, it's going to be taken into account as a new configuration option. So the payload, it was fairly simple. We have all the GraphQL things, and we ask for logs at a given revision, and the revision is --config alias.log. And it's exactly the same payload as packagist. And then you again get RC with a really silly argument injection bug and Mercurial. So this was a really good case, I think, of non-compliant parsing. I'm going to get back on this later. And last case, which is a bit more tricky, or it was tricky at the time, I think. This is in EL Finder, which is a file manager you have on your servers. It's like you have a kind of like WordPress, when you can drag and drop new files and media files and everything. This is saved by default. It does not allow you to send PHP files. It would be too easy, right? You can only send images, and then you can crop images with Image Magic. You can rotate images and so on. And you can also archive files, and you can also archive folders. And there were an argument injection bug in the archive feature, which is based on file name, or destination file name. And basically your value, the argument you inject flows into zip, RAR, or 7D. So this is what it looks like. We have on the top as an argument $name, which is the name of the archive we're trying to create that we control. And we have some line of code on the for each. I don't know if you're all fan of PHP. I am, but the for each and the array map only apply this escape function for PHP on all file names of the file we're trying to compress. We also apply it to the destination file name. We cannot inject arguments in the case of the file we're trying to compress, because they are at the very end. And as we see online, right after the for each, there's a dot concatenated with / and then base name file. That means there is a prefix, so we cannot put --. But it's not the case of the output file. So we can inject a new argument in place of the name of the destination file we're trying to create. So there are some options. We have the -t, which is test, like test the integrity of a file. Okay, good. There is the -tt, which is, if you're trying to test the integrity, use this command instead of the original one. So if you inject -ttt, you may be able to execute an arbitrary command. But in this case, if you put -ttt, it's not a valid argument. It's going to read the two t's and say, okay, the new command is t, instead of reading -t, like, oh, please test integrity, and then tt and the command, like, to redefine the command. So, how can we inject multiple arguments? And it's fairly easy in practice. You can chain short form arguments, like you have your first t, and then you put like a useless option that doesn't mean anything, like m, and you put the tt and your value. That means you can, then, if you're trying to zip a file name -tmtt and, our command instead is going to run date and put in the file foo. We could have put reboot and would have rebooted everything. So that means we can, with argument injections, we're not always limited to to injecting only one option. When you have these kind of short form options with one dash and one letter or two letters, you can inject several of them. If they have the same letter, you can put a dummy option in between. But you will always be limited to one option argument. That's going to be the last one, that we have with tt equal and our payload. So now we can look into prevention. In theory, it should be simple, with the POSIX specification that kind of defines all these behaviors and how command line works and what's called an argument and what's called a command. They also say you have this -- switch. All the arguments following this value should be treated as operands. That means they don't have an effect on the original command. They're not being considered to be arguments. They're being always considered to be operands, like strings. It doesn't stop argument passing. So if you put it after the -r of Mercurial, it's going to be understood as an option argument, which is a pitfall. But I mean, that's it. That's easy to fix, right? No. If you remember zip from ELFinder, if you try to do it with zip -a.zip, zip's complain. It says, no, you cannot use it before archive names. That means nobody can prevent argument injection bugs when you call zip, because zip doesn't support this -- thing. If you remember Mercurial from the packages example from SourceHot, it takes precedence over everything else. I mean, it's not a really conventional argument passer. The -- is maybe not that doesn't have that much effect. And same with Git from other findings. If you try to use -- in Git, it means something else. It means that you can only use it when you're trying to separate file names from, I think it's references from files. So they introduced -- end of options. That means Git, for some reason, doesn't want to do like the others, and created its own thing that has the same effect, but it's just different, and it's longer, and you have to know it. And if you don't know about argument injection, I don't know why you would wonder, maybe Git has something different than the others. So it's a horrible pitfall for all developers. And so that means there are various conventions. There is the original one that we've seen before. You have the GNU style option with -o, that means the same thing as -- option. There is the X11 Java fine kind of style with one dash and a long name. I don't know if you knew, but like for shells, sh as +a, for instance, to negate -a. So is there one convention? No. Everybody's doing their own thing. And there are so many edge cases with like option in an option argument. For Mercurial, it works. For the others, maybe not. Sometimes you can group short form arguments, like we've seen with zip. Sometimes you can't. Sometimes you have to attach the value of the option argument. You have to attach it to the option. So in some programs, these three things are going to be all different. For some of them, arg is going to be an operand. For some of them, arg is going to be the option argument. And in some cases, if you put the equal sign, it's going to be the value of the O argument is going to be equal arg. Everybody's different. And short form options, you've seen it so in zip. There is the -t, the -tt. Sometimes they only have it. And to add even more things and more complexity, sometimes the order changes. Like this POSIX specification is like, yeah, we can reorder things whenever we want. I would not expect my arguments to be reordered for any reason. And if I need to use my -- to separate things, it's like things before are not safe, but things after is going to be safe. I feel like the order matters in some case. So there is no consensus, there is no standard, and I don't know if people can try to protect themselves against this really vague risk. Every implementation is slightly different. And I'm not even speaking about non-POSIX systems. Windows, I have no idea how people on Windows prevent this kind of bugs. So I'm pretty sure there are a lot of argument injection bugs on Windows. It's using slashes and not dashes. So it's even very different. And in this case, is it the fault of packages? Yes, they introduced this argument injection. But maybe without this weird support of config by Mercurial, maybe it wouldn't have been that easy to exploit it. So is it the responsibility of packages to check that Mercurial complies and has some compliant argument passing, or is it Mercurial responsibility to try to mimic the others? But the others are all different. So what should they try to do in this case? So once again, we're going to tell developers to aggressively validate inputs, which worked really well for the last 20 years. We're not finding any kind of SQL injection, right? No, it doesn't work. You cannot tell people to validate everything. We've seen that it doesn't work. It doesn't scale. And it's even worse in this case because it's not always values coming from the user, like you've seen with packages in the form, like in the case of zip. It could be a file on the file system. So it's a second order source. And you would never say, oh yeah, I need to sanitize the name of my file because it could be unsafe. Nobody's thinking that way. Otherwise, you have to validate everything, not only things that come from the user. It's tricky. It's like you never revalidate data you get from the database because you assume that because there is this thing in between the user and you, that it's going to be safe. So there's some band-aids. You can still, maybe when you deal with path, use a prefix to kind of break the dashes and avoid these dashes to have any kind of effect. So for absolute paths, you can use slash, relative paths, dot slash. You can always use this form to avoid, to introduce new option. But operands in this case, you can also trim everything that's not A to Z and 0 to 9 from prefix. But that means for every single value you take from database, file system, the user, you have to do it. I don't want to do it, honestly. So we're also trying to make things, actionable things, for people. Like, even if this talk infuriates you, it infuriates me. But we're gonna, build constructive stuff around it. We've been doing this argument injection vectors list. It's like GTF for bins, but it's not GTF for bins. And we reference real world cases of, dangerous arguments, like in zip, like on Mercurial, on Git, on any of these. It needs to come from real world resources. We don't want to have a full list like GTF for bins with crazy vectors. We only want to have realistic ones. So this is open for contribution. You can use it. It's public. It's free. It's made for the community. And we've also contributed to Google System SAN, which is originally used to catch non-memory corruption bugs during fuzzing. So the way it works is you run a program and a test when you fuzz it, and you want to abort the execution when you have memory corruption. In this case, it's trying to catch non-memory corruptions. So it's trying to catch command injection by looking at shell errors. It's trying to find SSRF. It's trying to find path traversal by analyzing, like we've seen in conference before, weird behaviors. That means if it's trying to open things at the wrong location, and so on and so on. And it uses btrace to instrument the process in the test. You look on syscall, you inspect registers and arguments. And in our case, we contributed support for argument injections. We only look on execve, and we look at the argument list. And if there is a magic value that we see that the trier is trying to push for every test case, if we see it as a standalone argument, we say, oh, there is a risk that it's going to be interpreted as an argument, and we raise the issue. So we've sent 3 PRs a few months ago. Please, if somebody from Google is in the room, if you want to just review and merge, because nobody's taking care of it. And then we could maybe think about even going the extra mile by plugging System SAN to more dynamic testing tools, like Bob Sweet, ActiveScan, for instance. We could also try to list and classify. It's a small research project in this case. How can we classify argument parser attributes? All the edge cases that we've seen, all the weird standards and conventions, can we maybe automatically detect them from running the program to say this thing has a really weird behavior, it could be unsafe if there is ever an argument injection on him? And we can also try to introduce a list of argument injection vectors in more tooling. There is a 4-year-old argument injection armor, which is a Bob Suite plugin that's not maintained. So maybe we could try to do more PRs for this project, but we need to sync the project, and also for word list for researchers and bug bounty hunters and everything in general. So to conclude, I think there is a huge potential on the offensive side. It affects all languages, all APIs. There is no mitigation but education, and we know it doesn't work again. We need more tooling, more exploitation techniques to also know that it's really unsafe. It's, in most cases, it's as dangerous as a command injection, but it's seen as something else and something much less to worry about. But it's not the case. It should be seen as really a risk of RC. And there is also, good thing, huge potential on the defensive side. We could design less flexible but safer APIs for process execution. We could separate options from operands to automatically insert the dash sign and try to validate the data come from the user. So there could be compile time enforcement that all operands are validated. That means you could not put a string as an operand. It would have to be a special type. That means you are sure that you run some checks on it. And it's not like Rust black magic. Perl did it 20 years ago. So I don't know why we lost this kind of knowledge to always validate user input. And I think it's also good to have a better tracking of argument injection bugs. You cannot defend against something you don't know. So if we don't really track how often these kind of things happen, I don't really know how we can protect against it. Yeah, so good luck with your research. And if you find new vectors, new CV, you can send it to us and it's going to be cool. Thank you.